So some neighborhood has a 2 hectare park and 35 hectare residential area with a total of 3,934 trees. Sounds like a lot to me. A hectare is an area that's, oops, it's a metric measurement, but we do use it in the United States. It's 100 meters by 100 meters. So think of like a football field, a little longer than, well, football field with the end zones, each direction, right? So it's decent size, right? Like if that was a park, it wouldn't be huge. It's not like Long's Park big, but it's, if you stuck, I guess if you stuck 2 football fields next to each other, it'd be getting close to that, okay? But still, almost 4,000 trees, that seems like a lot, but I'd like to live there. That sounds pretty, if they're good. Anyway, so what's a good strategy for this? Like, I was just telling you the hectare thing, not because it's relevant to the problem, it's just interesting to know. But what's a good strategy for solving this kind of problem? In a test, like this is an SAT problem, right? So like what's a good strategy for that?
Draw a picture so you can visualize the problem.
Okay, yeah, drawing pictures is always a good idea.
I mean, it's kind of like a shot in the dark and maybe find the area.
Okay, well, you could. Now I'm gonna say this would be probably my strategy. Since it says which of the following is the best interpretation. So does that mean we have to calculate anything? It's just a description of what it is, right? So I guess, you have on the SAT app called Blue Book, you have that ability to highlight things, I think, right? You guys remember from last year? Okay. Anyway, maybe if you can't highlight a single word, maybe just write it on paper, right? Like interpretation. Because that really tells us that we don't have to calculate, we just need to understand what X represents in the problem. So number one, when I look at this, there's a lot of words, and you're in a time test, right? And so reading takes time. So it's a balance between reading too fast, so you have more time, and not reading close enough, which takes more time, right? So anyway, here's our equation. You could maybe just write it so it's not embedded in this paragraph, so we can see it a little bit. Okay, what was the 2 referencing? Okay, so this is something to do with park. What is the 35 referencing? Yeah. All right, so next strategy, since we can't solve, this is not one of those things where you can really solve and then go pick your answer. We have to know what they're trying to tell us and pick the right one. So that means we have to read them, right? Okay, the average number of trees per hectare in the park. Does that seem like an option, or should we scratch it out immediately, or what do you think? It's definitely an option, right? Because look, this says park, and X is with park. So that's pretty, I don't know how you do this, but maybe mark it, right? Okay, could it be the average trees per residential area? Probably not, because that's Y, right? So, total number? Well, that doesn't make sense. It told us the total number was this. I mean, it literally said that right there. Okay, so that definitely doesn't make sense. And then the total number of trees in the, sorry, I did say that wrong. Total number of trees in the park is not this one. But that's this whole thing. Okay? Anyway, same with D. So we end up saying, yeah, A makes sense after that. So in terms of strategy, this is all words. There's no calculating. So that sort of implies that you have to read carefully. Okay? All right, next one. All right, I'm just going to have to work with it like this. Still a lot of words, but now we have a graph and some equations. So you might get away with not reading as closely. Not saying you should do that, but do you get what I'm saying? Like, I see a picture represented by these, so I could probably skip to this part. At least to start, right? To save time. And some people don't struggle with timing on these tests. I always did. I'm a slow test taker, so I was always bumping up to the end. So test strategies that help save time were really helpful for me. So I could just read which equation could represent that. Then I don't have, who cares what it's about, honestly, right? For this. How are you going to figure that out? Like, which of these equations matches that graph? How do you, and it's not just one way, so maybe share how you did it. Aaron, how'd you do it?
Maybe if y equals x, then so kind of odd, like y equals x, then for every y you go over x and like subtract 12, or go over y, so every.
Okay. So it's probably good to review some linear stuff, right? Because at a very minimum, we ought to be able to eliminate really bad answers out of here. After all, SAT is every bit as much a game as it is knowing math, honestly, okay? These same people write the AP tests, and when you start looking at AP questions, it's like, do you really have to write it that way? You know, like, it's a little bit of a game sometimes. And by game, I mean like trying to figure out what they're not telling you, what they're implying, and how to get around their traps. Okay? It's frustrating. Honestly, it's frustrating. So, quick reminder, we saw this last semester, but what does this form tell you? Because I see two equations that are like that. Yeah, A and C are both like that. The number that's with x is the slope, and the number that's by itself is what? Yeah, that's the y-intercept, which means what? What is a y-intercept after all? Good job for knowing that, but what does that mean? This is a big deal, guys, by the way. Like, it comes up in every math class, pretty much.
Your intercepts on the y-axis?
Yeah, so that's this point right here, okay? Does everybody see where we're getting that? So the y-intercept of this function, or relationship, is what? Well, I just wrote right over top of it. That's dumb. It's 40. Okay, so knowing that this form tells you the y-intercept, and knowing by looking at the graph that the y-intercept is 40, what answers can you immediately kick out? Like, instantly. No calculating involved. C for sure. Well, before I cross it off, what is the y-intercept in C? It's 8, so it's definitely not that one. Okay? What other one can we cross off? A, because what's the y-intercept in A? 12. Also, these slopes are both positive. Is that a positive slope? That's downhill, right? So that's another reason that we could immediately kick those two out. All right, so now we have these two that look like all we did was change the 8 and the 12. So how are you going to use, in terms of strategy, I would just pick one to check the y-intercept. How do you check a y-intercept? And if the y-intercept's wrong, we know it's the other one, right? Well, what is the other coordinate of that point? So we know that the y-coordinate is 40, because that's the y-axis. But what's the x-coordinate?
0, 0.
It's always 0 also, right? Like any of these, like that point, 0, 15, 0, 5, 0, 10, 0, 20, 0, 30. It's always x is 0 for any function. I mean, even if this is some weird random looking thing, it's 0 on the x, for the x coordinate of the y-axis. Anyway, with that knowledge, what could you do in here? Like, just pick B and C. Since we know that y-intercept is 40, can't we set x to 0? Okay? So this is going to be 8 times 0 plus 12y equals 480. What's y? Y is not 12. That's what's out front of it. Y is what? How'd you get 40? Sylvana. No, but I'm saying, what is the value of this y in this problem? Like, you just solve it like a regular equation now, right? Like, this is, what is 8 times 0? How do you get y by itself? Just divide 12, right? What is 480 divided by 12?
40.
And so you know that that's the correct one, right? Because look what happens over here. Again, plug in 0 for x, that's gone. What happens when you divide 480 by 8? And just don't worry about that 0. What's 48 divided by 8? It's 6. This is meant to be a mental math. 48 divided by 8 is 6, with the 0 is 60. So is that one correct? So let me talk back a little bit, back through this. We know it's b. Let's say you didn't know any of it, like any of that stuff we just did. But guys, at a very minimum, you ought to know this is positive slope, and the y-intercept is not 40. And at least you've already doubled your chances, right? You went from 1 out of 4 to 1 out of 2. That's double your chances. Always, when you're doing this test, first of all, never leave a question blank. And second of all, try to eliminate something because your chances improve, right? Alright. That's one way to do this. Maybe we'll have another one come up where we can talk through another way. But that's probably the fastest way, is just to check y-intercepts on each one. Cool. Alright, yesterday we got back into similar triangles, similarity in general. How many of you went and reviewed your notes like I asked you to? Good job, Lena. Good job, Tanner. Bad job. I wonder if that flour mix that you had any dahlias in it. Did you know that's a flower? You what? Oh, do you know what it looks like? Does it look like you? Did you say it's green?
No, I think it's great.
Oh, it's green. I think you said it looks like green. That has a whole bunch in there. It could be. I swear I remember reading that when I bought it for my wife. But I don't remember for sure. I'll look it up before I look it up. Alright, well, if you didn't, you should still go review those notes. And it's not where they are. All this stuff. It's not a whole big bunch, like a page and a half or so. Anyway, so we're going to continue reviewing. We might be able to get through it all today, I think, probably. And it'll be interesting to see if you guys have any of this page still. If you have any of this worksheet, if you still have it. I don't. Well, it didn't have a name, I don't think. I think it was just problems on a page. So, anyway, we'll see. If you don't, I'll get you some. But let's start here. And so we want to solve for x. What do we have to know before we start? We have to know those triangles are similar, otherwise we can't solve. Do we know? This time. Like yesterday, just to remind you, yesterday we had these two marks that showed us that we had angle similarity. So we were good. How about this one? Do we know they're similar? Give me a thumb up or down. Okay. How? But that's only one angle.
I guess the 15 is half. 30. Oh,
Do we know they're similar? Go ahead.
is it side and side?
It's not, because we don't know x. if we knew x and it was in the correct relationship, then we could use side angle side. So good job of thinking of that. But technically, there's not enough information to conclude they're similar. Because we only have one angle and one relationship between side lengths, which isn't enough. Remember, it has to be two sides at least. Either all three sides or two sides and an angle. So technically, this is not a doable problem the way it's written. But if I put a congruent mark here and here, now do we know that it's okay? Okay. So with that marking, what proportion did you set up? How about you, Bailey?
I did CBA and then FEB are similar. So in that case, because there's angle angle.
Now it is, yeah. Okay. And what ratio or proportion did you set up to solve for x?
Times 2.
Okay, so she just did 30, except it's not times 2.
I just did the opposite way, so I did the small to the big.
Okay, what is big to small? Somebody else, help her out. Not saying that you don't know.
No, you're okay.
So big to small proportion, or ratio rather. In other words, scale factor going down. Because remember yesterday it was destination value divided by original, where you started. So we're headed to 15 and we're starting at 30. So how can we set that up into a ratio? No, that's the opposite way. We're going to 15 from 30. So 15 over 30. That's okay, you could use it like that, but that reduces to a half. And doesn't that make sense? Like 30 times a half is 15. Okay, so that must mean this has to be times a half as well. You agree? For it to be proportional and similar. I think all of that is harder than this needs to be, because can't we use a proportion like this thing? What'd you set up? Equals? Okay. And then we just do 30x and then 15 times 36. And then x is, what is that, 18, 180? No, 18. Either one is okay. Sometimes you can see the relationship, so good job seeing that. But I do want you to be able to do proportions as well. How many of you did the scale factor version? Like just looking at the fact that 30 is double of 15, so 36 must be double x. So good job seeing that. Okay, raise your hand if you did the proportion version. Carmen, how'd you do it?
Oh, I did it.
Okay. Or you have some calculator issues?
Yeah.
What?
In physics, some guy messed with it to like where it rounds to the third number only, and that was messing me up. Every time I did like, for example, 3 times 3, it'd be like 3 are like 9.000.
Uh-huh.
It's weird.
That's kind of annoying. We can fix it if you want.
Like look, I put in a 9, it's like all these extra zeros.
Let's fix it. That's probably, is this an AP class?
Oh no, it's just normal physics. But
Yeah.
we're doing like scientific notation.
That's good to know. That means I could do some scientific notation problems. No.
It's been a long time.
Like what if this was 30 times 10 to the 4th? And this is 15 times 10 to the 2nd. Now can we solve it? Does that change the value of x? Why? Well, this is to the 4th power is 2 10 powers bigger than the 2nd power, right? Which 2 10 powers is 100, so you could just tack on 2 zeros. Okay. So, alright, good to know. Scientific notation is weird but kind of nice, don't you think? As long as you're dealing with big numbers, it makes sense. This wouldn't make sense unless you had a huge triangle. All right. So then we took that same concept, because it's exactly, if you look on the left side, those two problems we just did, it's the exact same thing. It's just using similarity to solve for lengths and triangles. Only we had these applied problems, right? Like stories where things like our shadows, our mirrors, where they created similar triangles that we could use to solve. Will you look for this just to see if you have it, this sheet? Okay, so think about this process that you would do. It says a bush is sighted on the opposite side of the canyon. So obviously we're over here. And we would walk until we're across the canyon from some landmark, like a bush or tree or a big rock or whatever. And we have canyons all over here, so this seems relatable, right? Anyway, and then it says find the width, so that's this distance across the canyon. How would we set up this side? Like what else would you have to maybe do, like to make sure all these measurements are accurate? Any thoughts? Like I want you to picture you're on the edge of this canyon. We can't go over there, but we don't need to, which is really cool, right? Just like we didn't have to climb the tree to measure it, we could measure shadows and stuff. So how could you set stuff up that would make these triangles on your side?
Maybe like you broke, or wait, put you in the ground and you tape measure or something?
Okay, yeah. You could put like a stake or a rock, like set a little boulder on the ground, and then you could pace or measure out 100 feet. Put a stake there, okay, and then 10 more, put a stake, and then you're just measuring along. Now, how would these two blue points, let me make those a different color for a second. How would these two red points have to be related to that bush? Like it can't just be arbitrary, walking around putting rocks on the ground or stakes, right? Yeah, you're getting there. What do you notice about those 2 points and the bush in the picture? They're all lined up, right? So in other words, I have to make triangles. I couldn't just put this second red point couldn't be like here, right? And then we're like, well, where does that line up? Like it lines up that way or something, right? So it has to make this overlapping triangle. We saw another version of this. Let me go back to that picture and remind you. Let's see. Here it was. Okay. This time the triangles weren't like the bow tie kind, right? They were just in line. So, but any case, we have to have our points in line. Otherwise, it doesn't make. Can you put that away? It doesn't make a similar triangle. It's just stuff on the ground. Okay. It would be a little challenging, but we could do it. Do you remember that problem at all? Okay. That one's actually harder than this one, so that's good news. I would redraw these two triangles just so you have kind of the usual picture that you're looking for. And there's the big one, and then the little one, we have to, if we flip the picture, you just have to make sure you label it correctly. So what goes here? Yeah, that's our 7.5, and then here's our 10. Okay, what makes these similar? We didn't ask that, but we have to have them be similar before we solve with them. So what makes them similar? And there's yes, good job. There you go. Right here, there's a pair of congruent angles, and she called them vertical angles. Remember that phrase? We use those a lot. Anyway, those are congruent. To make this angle, we have to have another pair. And it's not shown here, but what probably is the measure of this angle here? Yeah. Okay, those, if you set it up right, those would both be 90. So now we have angle similarity. Anyway, what's a good proportion to solve for x? Braden, how about you?
I do like the x over 7.5 percentage.
Perfect. That's awesome. Okay, and you can look here, this numerator is 10 times bigger than the denominator. So we know same thing must be true over here if these are going to be proportional. Or we can do like 10x, we can take our butterfly equals 75, or excuse me, 750. And then just divide, and you'll get x is 75. And it's feet, so 75 feet wide. Not a super wide canyon. How'd that go? Did you get it? Awesome. Okay. We had, I'm not going to have you do these at the moment, but like, remember when we had triangles within bigger triangles? We saw a version of that yesterday. Okay. So anytime we have similar triangles that we can set up or observe, we can use this structure to solve. It's cool. So on yours, before, here we go. We did numbers 1, 2. Did we do 3? Circle 3 then if we didn't do it. Circle 4. On on 4, just make sure you draw your triangles with the letters in the right place to be corresponding. Otherwise, this gets kind of messy. So, how about on the back? What do we do there? Did we do 7? Mark 7. And 11 is like the one we just did. What does this mean? Why does it have to have that on there?
It's not the real scale.
What?
It's not the real scale.
Okay, what does that mean though? It's not quite what it means. Well, I guess, what do you mean by real size? You kind of both said the same thing. Like, obviously the town isn't my hand, right? So what do you mean by that?
It's like a more, I don't know how to say it, like, understandable.
Okay, it actually has an official meaning. Here's what it means. In the picture, it looks like I could take this town length and maybe like, I don't know, what do you think? Go 1.5 each direction, maybe? So the whole length would be like 1, 2, 3, 4 widths of the town. Do you see what I'm saying? And then we could maybe take that down here and say, oh, well, that looks roughly the same as this, so the town must be 1.4. And that must be 4 of those, so that's not, you can't, that's what it means. So not drawn to scale means the lengths in here are not shown correctly relative to each other. Versus like has anybody ever seen a blueprint? Okay. I'll pull one up while you're working on these. Those are drawn to scale. Like, let's say I wanted a blueprint of this room. Obviously, this paper is not the size of the room, right, that I'm going to hold, but it means that, like, if I show this to be 4 inches, this wall on paper, then that better be the correct relationship to those 4 inches and maybe be like 3.5 inches, right? So all the relationships are consistent. All right, so why don't you work on those, and I'll pull up a blueprint for you to look at. I have some of Some cool stuff. I don't know. What do you want to see? All right, let's go ahead and start just with the first, like the earlier problems. So number 3, right? This is what we did outside with the tree, only we have to draw the picture instead of just visualize. So it says a tower casts a shadow. So, are you sure we didn't do this one? Okay. So we're going to make like a castle tower. And I'm no artist, but there's this. Here's our shadow, 7 meters long. Where's the sun, that means, right? Where's the sun? This way. Yeah. I thought I could do better than that. That looks really stupid, but that's okay. Okay, a vertical stick. Like, think of taking the meter stick out there, because we know exactly how long it is, right? So, a vertical stick casts a shadow 0.6 meters long. And if the stick is 1.2 meters, how high is the tower? Okay. So first of all, when you draw it like this, you don't see triangles, but we know that that sun is coming down at the same angle, making 2 similar triangles, okay? This angle is, we'll assume it's 90 for both, and then the angle that the sun makes is also congruent. So we have our angle similarity. Anyway, with this, what's a good proportion to solve for the height of the tower?
1.2 over x equals 0.6 over 7.
Awesome, good job. Okay, so we're going to multiply 0.6 in x, and then 7 times 1.2 is that 7, 8 point, what, 8, 4? 8.4, okay. And then divide by 0.6, remember when you divide by a small decimal like that, it makes the number get bigger. What'd you get? Somebody, what'd you get?
14.
14. Just right on the nose. Okay, so 14 meters is about 45 feet. So that's pretty tall. It's like 4 stories. Okay, next one. Now your picture might look a little different in terms of the order of the letters, which is fine. I guess this one's bigger. Okay. I'm not going to draw it that much bigger, but it's just bigger, okay? IJK. You guys still say JK? Some of you. Anyway. JK. I'm going to go this way. And it doesn't honestly matter as long as the length of the longest side matches up with your 50, because it's the longest side. So it has to show as corresponding. In other words, if I put 275 here, that would be wrong because it's not corresponding to the longest side of the littler triangle. Okay? So 275 has to match up with 50. And then we could call this X and Y, or you could just use the letters UT and TV to solve, either one. Okay, what's a good proportion to solve for what I've labeled X? Silvana, how about you?
40 over x equals 50 over 25.
Good. And then why don't you do Y too?
24 over y equals 50 over 75.
Cool. Good job. Now, notice that we can use this known ratio for both of our ratios. It's okay. Okay. We don't have to switch that up. So we'll do 50x equals some fairly big number, and then 50y equals some littler number. Can you guys, I can pull this up, but if we have consensus, we can just go with it. So what did you get? 220 for x. And y? 132. Okay. I'm seeing some nods. Did you get that? She did. Yes. Yes. So that's 4 people. Okay. All right. Any questions on either of those two? Okay. Yeah, it did. Stickler up here in the front. Guys, perimeter means what? The whole distance around. So we're going to add 220 plus 132, which is 352, plus 275. So P equals 220, 132, 275. So 352 plus 275. What'd you get? 627? Okay. Now, is there any questions? Okay. Good job for catching that. I should have remembered. So you guys did this too. Remember setting that mirror on the sidewalk outside? And then you had to walk around so you could see the top of the tree, which was kind of weird because it was hard to tell. Then we measured your feet. So think of like, I guess that's too tall. Because remember, where did this have to go? Where did that measurement have to go? Do you remember? When you were measuring this, where you had to measure to? Yeah, to your eyeball, not to the top of your head. So that's your eye, okay? But we have two triangles. These ones honestly are pretty well set up. I don't think I need to redraw them. Did you? Yeah, I agree. So what's a good ratio to solve for x? Or proportion, rather. How about you, Karen?
7.5 over 45 and 8 over 6. Or no,
8
6.
should be 6, yeah. That's a tall dude. Okay, anyway, so 7.5x equals 270, I think, right? And just divide, what'd you get for x, Kyron? Loading, please wait. It's okay. Cool, thanks. Alright. And then this last one. So this is that kind of, I call it the bow tie shape, kind of triangle shape. So we have this known relationship here, and we're going to have to use that to set up the other. So 1.2 to 7.5. The way I've drawn it, it's small to big. So as long as you're consistent on the other side, you'll be okay. So the other side should be 1.4, and we're going to call this x. Any questions on the setup? Okay. Alright, and then divide 10.5 by 1.2, and we get 8 3/4. Have you guys all been to Denver? What are we in here, Miles? Have you all been to Denver? Yeah, okay, sorry. So, if you ever look at a top view, so like a map of Denver, it has I-25, I-25 that goes right through, right past the Empower Field, past the big tall buildings, north and south, right? Okay, so like Empower Field, tall buildings, and I-25 goes right through. So it's down in the heart of the town, and it's busy and slow, and people are commuting. But then they have this loop that goes around, which is I-225. And that's kind of what this is. It's like you could drive right through the town to get to the other park, or you could take this faster road that bypasses all that downtown stuff. Okay? I mean, over there everything is busy, so it probably helps only a little. But that's kind of what we're talking about here. Like, how far is it? It's shorter to go directly through the town, but it might be faster to go the longer distance because you can drive faster, okay? We kind of have that here. Highway 50 is kind of, they call it I-70 business loop, right? That takes you all the way down through town and it's really slow, and you could just get on I-70 and bypass the town, right? It's kind of the same idea. Anyway, so we know that that's 8.75 miles. Now we have to figure out that secondary distance, which means we're solving a triangle. I'm going to put it over here, like this one. So our hypotenuse is 8.75, and that other side is 7.5. So we need, this would be A to R. That's this right here. I'm going to call it Y. In a right triangle. So do you remember Pythagorean theorem would say y squared plus 7.5 squared equals 8.75 squared? How would you solve for y? Just talk me through that. Well, you guys, we still have another minute, a couple minutes. You don't have to pack up. Shame. How would you get y by itself?
Could you combine the 7.5 and 8.75?
Yeah, you can combine those as long as you square them first, right? So 7.5 squared, 8.75 squared. So help me remember these numbers. 5625. It's not writing nice. 5625 and 7656. Okay, now what?
Now subtract 56.25 from 76.56.
Yeah. Okay, so this is gonna look weird, but just trust me on it. There we go, so 20.31. Okay, how do we undo squared? Square root. This is definitely gonna look weird. That's the same as the 1/2 power, so 4.5 miles. Okay, so look at what we're saying. If you go straight through the town, you drive 8.75 miles. If you go the long way, you're going 4.5 plus 7.5, which is 12 miles. So it's roughly 3 miles longer, but it's likely to be faster if the town is busy. Does that make sense? How'd that go for you? Alright, we didn't have a chance to look at the blueprint, so just tuck that away and we'll talk about it tomorrow.
If everyone's going 70 miles per hour, you have to follow it.